Hello, everyone. Welcome back. We have 3 video lectures that cover Chapter 6. In the first one, we're going to be covering exactly what data management is, why it matters. We'll look at the different sources of data. We'll look at the different types of data, both clinical and administrative. And we'll look at systems like EHR, lab systems, imaging, and others. We'll learn about system characterization and the difference between raw data elements and information. People use these terms interchangeably. They're actually very different things. So let's have a look and get started on data management. Okay, again, we're covering data management, a critical topic in health information management. So let's talk about what it is. Data management is managing data. But in order to do that, we need to be able to define the different data elements and be able to understand how they're created, how they're stored, and how these data elements are transmitted to others so we can share information. Organizations, whether it's a hospital or a medical office, need to know and understand how the data is produced, why certain types and formats of data are produced, how it's stored and managed, and how to ensure data integrity, which we'll get into in a little bit. Data sources come from everywhere, and we normally think of things coming from electronic health records, but they come from other sources as well. Data elements come into an organization and they go out, and we'll get into that in a little bit more depth shortly. But before we get into that, we need to think about the different sources of data and the types of data, including clinical data and administrative data. So we can kind of think of these in two broad camps. So the clinical data is obvious. It's everything related to patient care, as you can see on this slide. The administrative data is everything else. It's the billing data, it's the demographic data, it's the address. All those things don't directly impact patient care, but they're still important. Now we can talk about some of the common data sources in healthcare. The EHR one we've covered, but we also have practice management systems that have schedules, physician schedules in the office, right? Or the OR. We have lab information, right? We have radiology information systems. We have the PACS systems. PACS is very common, stands for Picture Archival and Communications. So all the digital images of an actual X-ray, not just the report. And then we have clinical documentation systems that range from home health, long-term care, mental health, all different types of things. The master patient index, and then we have other patient indexes. These could be essentially, think of them as databases that round up everything from a log of all surgeries to an autopsy log. All these things are examples of indexes. We can also have disease indexes, which we'll talk about in a little bit, that cover such things as diabetes and other conditions. We've covered databases a little bit, and if you've taken HIM 125, you've actually gotten to work with some databases, so I don't want to spend a whole lot of time on it. But related to that is the idea of registries. Registry is a word, whenever we say that, the next thing that people want to associate it with is cancer, but there are actually diabetes registries, IBD registries, depression registries, all different types of registries in healthcare. When we talk about this term system characterization, we're basically creating an inventory of all the systems that contain data, including documenting where the data is stored, what type of data is created, stored, managed, and with what hardware and software they interact. And then we need to also provide basic security measures for these systems. So you can almost kind of think of it as a mind map for your data. You're creating inventory of all these systems, how they relate to each other, what they contain, how they interact. And when you do that, then you're able to provide basic security. If you don't even know what you have, you really can't provide basic security. Now let's talk about an important topic: data elements versus information. People throw around data, information. I need data, I need information, and they're related, but they're really not the same thing. A data element is a single fact that is the smallest unique subset of a larger database. So this is just a piece of data. Could be date of birth, gender, blood pressure, temperature. But without the whole context of other data elements and the perspective, we don't have anything in a meaningful content, right? So the example where they give A1C, just an A1C result is a data element. In the context of taking those data elements and of patients who have had a diagnosis of a heart attack, then it becomes meaningful information. We've talked about data dictionaries in HIM 125, and I'm going to talk about them again. This is basically, you can think of a data dictionary as a roadmap as to how you're going to manage your data. And let's go through this a little bit. So in this case, we have a data field, and this one's admission date. This is how it's named in the database, admit underscore date. We have a definition, right? It's the date the patient is admitted as an inpatient. So what type of data is it? It's a date. And then really important part, the format, month, day, and then 4 characters for the year. And then the field size. In this case, it's 8. And then they have values, right? The source system, right? And then why the item is included. This is a great example of a data dictionary. So when we talk about data dictionaries, it's this type of thing. If you go back to our example of admission date, if we had people that were just writing the month out, like November, and then typing out 14, right? And then the year, and just say 2 digits for 25 or what have you, and then other people are doing it differently, you're not going to be able to pull reliable data. Data sets are a list of data elements that have been defined and have uniform definitions that are specific to a type of healthcare industry. And let's take a look at some of them. One that you're familiar with from coding is the Uniform Hospital Discharge Data Set. We also have the Uniform Ambulatory Care Data Set, and DEEDS, and the Minimum Data Set, and so on. What these things all have in common is they're a recommended list of data elements that have been defined and are uniform, that are specific. So acute care hospitals always have the UHDDS. Databases we've worked with in 125, we worked with SQL and we've worked with Access. And regardless of what type of database, that's just the software piece of it. It's a collection of data that's organized in a way that the contents can be accessed, managed, reported, and updated. You could almost think of it as a large file cabinet. When we use the term relational databases, we're talking about databases that are in tables that are predefined that contain rows and columns of information. If you recall from HIM 125, records typically are rows, the fields are typically columns. We also have object-oriented databases, and these store different types of data, images, audio files, documents, and other data elements. And again, database lifecycle, this is very, very common in healthcare. So let's take a look at this. We at first determine the need. Why do we need a database? Maybe we have a lot of patients with diabetes, so we're going to have a diabetic database to track these patients, see if they're getting their medications filled. Then we're going to design it. What data fields do we need? How are we going to structure it? Then we're going to implement it. Then we will test it and evaluate it. Then we will actually use it and maintain it, right? And ensuring that does it need to be updated or not? Do we need to use different software? All these other things are the last step. And maybe we'll determine that we'll just keep going with it. Indices are basically a list from a database that provides us guidance, right? Guidance to information that we want to use. And it serves as a guide to locate something within a database or another system. You can kind of think of these as logs. And I'll give you some examples here. Master patient index. This is everybody who's been seen at a facility. Everybody has a name, a date of birth, a medical record number, and so on. We also could have a disease index, right? Almost like a registry, right? When I worked at Stanford, we had a lot of different types of cardiovascular disease indexes or indices, if you will. We could also have an operation or procedure index. So kind of thinking with the cardiovascular, maybe we want to track everybody who had a heart-lung transplant. And then finally, we have physician indices, right? Everything about all your attending physicians in one place. When we talk about data mapping, what we're doing is we're connecting two systems. And this is almost like what we call joins in if you've ever done any SQL work, right? So we have source data, which is where the data originates in a database, and then we have target data. So in other words, that's where we're mapping the other data to. So here's a great visual example using cholera, right? The ICD-10 code here is the source data. So we have A00.00, unspecified cholera. And then we want to look at the target data and find something that's equivalent in SNOMED CT, right? So in SNOMED CT, the code is going to be 636-50001. That's all I have for this video lecture. Our next video lecture will talk about more about data structure, mapping, and data governance. We'll see you then. Bye now.